Hello Legacy students. So today we're going to do finding all of the zeros, and that's right, all of them. So you're going to want your notes, a graphing calculator or Desmos will suffice, and then a pen or a pencil. So to find all the zeros, here's your steps. First of all, you're going to want to get a hint to get started. That is when we used our graphing calculator, be able to look at the graph, see where it crossed the x-axis, okay? Then you're going to set up your division and find the quotient or the answer. And then you're going to factor the quotient once you rewrite it in a polynomial form. And you're going to find and list all of the solutions that you find. Now, there is a very special theorem. It's known as the fundamental theorem of algebra. And the fundamental theorem of algebra is this. The number of solutions a polynomial has is equal to its degree. So if I have 3 solutions, that means that I will have, a degree of 3, that means I will have 3 solutions. If I have a degree of 5, I'm going to have 5 solutions. No, sometimes these can be integers, fractions, square roots, which means that they're irrational. Double counted solutions, so that's x plus 2 and x plus 2 twice happening. And you could even get imaginary solutions. So let's take a look at a couple of examples here that we are getting. So I got f of x equals x cubed plus 5x squared plus 4x plus 20. And I graphed that on my graphing calculator here. Here's a picture. It's not a very good list, but hey, it's going to give me a 0 at the very least. Well, it looks like it crosses right here, which is at -1, -2, -3, -5. So if you'd graph it on Desmos on your graphing calculator as well, you'd find -5 would be perfect. So let's use -5 as one of our zeros. Let's see if our educated guess is going to work. Let's set up our synthetic division. So I'm going to have a 1, a 5, a 4, and 20, because notice no one skipped. 1, -5, oh, getting a 0. Whoop, that's 0. 0 times -5 is 0. That's 4, -20. Whew. Got a smiley face. Got a 0. So, -5 is one of my zeros. I'm going to put x equals -5 over here. Otherwise, I'm going to forget about him. So, then, let's rewrite here. I got x squared plus 4 equals 0, right? You know, we've solved this problem before, back when we were solving quadratics. So we're going to want to subtract 4 first, because we're going to get x squared alone. So I get x squared equals -4, because 0 minus 4 is -4. Let's square root both sides, and we're going to get x equals, can I have a negative, so I'm going to get an I, plus or minus 2i. So my answers, 2i and -2i. So I got my 3 answers. 1, 2, 3. Those are my zeros. Now, on what are the factors that brought upon these zeros? Well, one factor was the x plus 5. So basically, what would cause me to get x equals -5? X plus 5. This one, though, the one that got me the 2i and the -2i, was this guy right here, the x squared plus 4. So that would be 2 factors that got me my zeros, and my zeros are -5, 2i, and -2i. Let's take an example of the next one. 3x to the 4th plus x cubed minus 10x squared plus 2x plus 4. Wow. So I'm going to have 4 answers, it looks right. Here's a graph. It looks like we cut through 1 right there, right? So let's do 1 for my thing here. I got 3, 1, -10, 2, and 4. No skips, so that's pretty good. Let's drop a 3, 3, 4, 4, -6. -4. Smiley face, we got a good answer. So let's write that off to the side here. I got 3x cubed plus 4x minus 6x minus 4. Oh, hold on. That should be squared. Now, let's see if that's factorable. So I got 3x cubed, 4x squared, negative 6x, and negative 4. Looks like we just got an x squared going this way. And an x going here. Oh, probably 3x going that way. There we go. Negative, oh, just a 4. This looks like a 4. And negative 2 doesn't work. Oh, you know what? Factoring doesn't work yet. Frowny face. So what I can do now is synthetically divide another time. So let's go over here. It looks like we got another really good 0 right here at negative 2. So let's take the negative 2 in and see if that's going to give us a non-x cubed that will be factorable. So I get dropped down to 3, negative 6, negative 2, 4, negative 2, 4, and then since that's smiley face, we don't worry about it. So I got smiley face. Now again, let's rewrite. So I got 3x squared minus 2x minus 2. But it factors. So I got AC of negative 6. 1 and 6. 3 and 2. None of those are going to give me negative 2. I don't have any other really nice factors. How can I solve this problem? So I got a quadratic. It's not factorable. Completing the square would really stink. Let's go with Old Faithful. The quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b, negative 2, so I got a positive 2, plus or minus the square root. B squared, negative 2 squared, minus 4 times my a times my c, all over 2 times my a. So I got 2 plus or minus the square root of 4. Negative 4 times 3 is negative 12, times a negative 2 is a positive 24, all over 6. 4 plus 24 is 28. Now you can't take anything out of these guys though, because you gotta have it all. You gotta simplify this down before you start simplifying numbers. Okay? So 28, 4 and a 7 come out of that. So I'm gonna get 2 plus or minus 2 square root of 7 all over 6. Well, I notice all these guys have something in common. So let's take a 2 out of everybody. So I'm going to have a 1 plus or minus 1 square root of 7 all over 3. So off to the side here, who are my zeros? Well, 2 of them are up here. 1 and negative 2 worked. And then I have my big guy right here. He counts for 2 because he has a plus 1 and a minus 1. So there is my 4 zeros. The factors that came upon this would be x minus 1, x plus 2. That's going to give me these guys, right? And then this big guy came out of this. So I'm going to have to write that all the way out. So what would happen is if I multiplied all of my 4 factors together, I should theoretically, if I don't mess up, get this problem back, which is a wonderful thing to be able to check if you ever do want to. And that's the end of this video. See you later, Sabers.